Afternoon, sir.
Good afternoon, good
Good
afternoon.
afternoon, sir.
Hi everyone. All fine?
Sir.
Super good. All right. Breakfast, lunch, what time is it? Almost lunch time. Correct? Next class, lunch, or you have one more class?
Lunch, sir.
Lunch. Biryani.
Sir.
No biryani? Yes, biryani.
Chapati.
Chapati. All right. How many eat biryani? How many like biryani?
Yes, sir.
Yes, sir. Very few. Okay. Biryani can be any biryani, veg or non-veg.
Non-veg, sir. Non-veg.
Veg.
Non-veg. Non-veg. Some
Non-veg.
girls from which class is this? Raibag 2
Veg.
maybe.
Sir, veg, sir.
Raibag 2 last bench girls, they're like, sir, biryani. As if I'm giving you a biryani, yeah? Okay, yes, those girls only. All right. Please move front, no? Please move front, people, so that I can see you clearly. Yes, last bench. It's okay, move front, come front. Come front. I told you, right? If I don't see your face, then I can't recognize you when you're in Bangalore. Bunny, Ali, last bench girls also. Raibag 2. Last bench girls, come front, people. It's okay. It's okay. Very good. All right. Okay. So, other classes also. Guys, please come in the front. Nipani 19. 19 boys. Please sit in the front row. Bunny pa. It's okay. Nothing will happen. Come front. Girls, boys. Last bench boys. 3 people, boys. Come front. Bunny munde. Come on, guys. You have to be proactive. Huh? Okay, all right. Done. So, we'll continue with continuity. I'll just briefly tell you what happened in the last class. Okay, I'll not go into the details. Just a quick recall of what was done in the last class. You have one more class after this, or this is the last class for CT?
The last class, sir.
Last class. All right. Yes. New Pure Ibug, the backbenchers are still a part of the class? Yeah?
Sir.
They are. Okay. If you go 2 more benches, you'll go to the next classroom. You'll penetrate the wall and you'll go to the next classroom. Okay? All right. Here we go. So, lot of people, happy to see you all. We'll continue. Okay, we'll continue with the class. So, continuity. I think today is 18th if I'm not wrong. Okay. So, what did we discuss mainly in the last class was? Mainly
Signum function.
Yes, we discussed signum function and we discussed
Modulus function.
yes, we discussed modulus function also. We discussed what happens to the left and to the right. It's very important. Whenever we are discussing about continuity, what is very important is we need to check what is happening to the left of the function and what is happening to the right of the function. What is happening to the left and what is happening to the right. Say for example, I have a function like this and say this is the point x is equal to a. This is the point, say x is equal to a. And at the point x is equal to a, y will have some value. Y will have some particular value at x is equal to a. So, y will have some value at x is equal to a. So, this point is what? It's on the left of a. This point is on the left of a. This point here is on the right of a. This point is on the right of a. So, now what is very important is whenever I use the word left of a and right of a, I'll give you an example. Say if I say x is equal to 4, what is to the left of 4? 3, 2, 1, everything. Am I correct? Left of a is 3, 2, 1, everything. What is to the right of x?
4.1.
5, 6, 7.
5, 6, 7. But please keep in mind, in continuity, whenever I use left and right, I am talking about immediate left, immediate right. I hope you are understanding. Say for example, in many of the classes, 3 people are sitting in a bench. 3 people are sitting in a bench. So for the person who's sitting in the middle, when I say left, don't go to the person who's sitting far away. Immediate left, immediate right. I hope you're understanding, people, yeah? So whenever we
Yes,
talk
sir.
about left and right in continuity, I'm talking about which points? I'm talking the points immediately to the left and immediately to the right. So people who are sitting in the middle. So what is left and right? People who are sitting next to you, not people who are sitting far away. You have to consider which points? You have to consider your friends who are immediately sitting next to you. I hope you are understanding when we use word immediate left and immediate yeah, right? Yes? Yeah?
Yes,
Yes,
sir.
sir.
So, what is very important is whenever I use left and right, I have to talk about immediate left. So, which are the points on the immediate left?
3.9999.
Yes, 3.9999, so on. And which is the immediate right?
4.00.
Yes, immediate right is going to be 4.0001. It does not matter how many zeros you include, 4.0001. That's very important in limits. When I say I will not use the word immediate, please keep in mind when I keep explaining, I will not use the word immediate. But it is understood that I am talking about immediate left and immediate right. That is very important. Now, if I have to check the continuity of the function at x is equal to a, what did we learn in last class? Was the modulus function is done, I believe? Yeah, we discussed modulus function.
Yes, sir.
Yes,
Yes, sir.
sir.
Is modulus function continuous?
Yes,
Yes,
sir.
yes.
Yes, sir.
All right, it is continuous. What about signum function? Is it continuous?
Not at
No,
x
sir.
equal to
Equal to
0.
0.
Yes,
point.
very good. Whenever we discuss continuity or whenever I say a function is continuous or not, a function can be continuous at all points. So for modulus function, f was continuous at all points. Am I right? F was continuous at all points. But for signum function, was it continuous at all points? Where was the function
Sir.
discontinuous?
0, 0.
Yes,
0.
it was
It's equal to 0.
discontinuous. Yes, it was discontinuous at x is equal to 0 and continuous at all other
point.
points. When x was not
Other
equal to
point.
0, it was continuous. So what is very important, whenever I talk about continuity, when I say it is continuous at all points, which means for all real numbers values of x, it is continuous. But if it is discontinuous at a certain point, we have to be very specific. All right? So this is one point. Now what is happening is, what is very important in limits and continuities, what we should check, whenever I am checking the continuity of any function, I should check if the left hand limit, that is if the value on the left, if the value on left, if it is equal to the value on the right, this I need to check. I need to check if the value on the left is equal to value on right. If the value on the left is equal to value on the right, can I say the function is continuous?
Yes, sir.
Yes?
No, sir.
Whoever told no? What is incomplete in my definition?
LHL equal to RHL equal to f of x.
Yes, it should also be equal to value of the function. If my left and right are equal, not sufficient. If I have to go from left to right, I should go very smoothly. If I'm jumping from left to right, it's not continuous at that point. So this is not the only condition. For function to be continuous. My left hand value should be equal to my right hand value, and also it should be equal to value at that particular point. It should also be equal to what? It should be equal to the value of the function at that particular point. So it is not just about the left, it is not just about the right. my left and right should be equal. It should also be equal to the value of the function at that particular point. So it's very important. Left and right are immediate neighbors. This is also told. When I say left of A, I am talking about my neighbors. I'm talking about my neighbors. I'm talking about the immediate neighbors. I've already written the word immediate. I'll not repeat. So neighbor of left, the neighbor on the left, the neighbor on the right. Okay, this is what we discussed in the last class. LHL and RHL, even if they are very close to each other, when I'm going from LHL to RHL, am I going very smoothly or am I jumping and going is the question. And we cannot draw the graph all the time. I'm not telling it is impossible to draw the graph. Graph can be drawn. Definitely for each and every function, we can draw the graph. But it's not a feasible method. It's not a convenient method. It is time consuming method. So what do we start doing? We check the left hand limit, we check the right hand limit, and we check if it is equal to value of the function. So today's class, I will be discussing about one more function, which is going to be greatest integer function, and then we start taking simple set of problems. All right. Next, I go to the greatest integer function. Have you come across greatest integer function? Yes? All right, let me take an example and ask you what's the greatest integer function. Let's take up a simple example. Now, if the greatest integer function is usually represented like this, f of x, y is equal to f of x is represented x in the square brackets. Now, when x is equal to say 1.46, what is the value of the greatest integer function?
1.
It is going to be equal to 1. Very good, no problem. Very good, correct answer. All right. So basically, whenever x is between 1 and 2, whenever the value of x is between 1 and 2, what is the value of y going to be?
1.
You always, very good, you always have to go where? You always have to go to the previous integer. Is 1.46 between 1 and 2? Do you all agree 1.46 is between 1 and 2?
Yes.
If x is between 1 and 2, what is the value of y according to the greatest integer function? You have to go where? You have to go to the previous integer, that is the integer on the left. So y will be equal to 1. So greatest integer function for 1.46, this is x for you, this is x for you, then the value of y will be equal to 1. The value of y will be equal to 1. Let me take one more example. If x is equal to 7.9999, what is the value of y?
7.
Yes, you go to the previous integer, because 7.9999 is between which two numbers? It is between 7 and 8. Where did I say? Where do you jump? You jump to the
Previous number.
previous integer. You jump to the previous integer. Greatest integer function. We are just discussing. It is between which two integers? Whatever number is given to me, it is between which two integers? Now, one last thing before I go to the next question. Okay, let me ask this and then go to the next question. Now, if I say x is equal to 3.75, what is the value of y? 3. Value of y is 3. Now I have a question for you. Now, as you told 3.75, if x is 3.75, I have to go to the previous integer. Which is going to be 3. Now in this inequalities, I have written 3 inequalities. Equation 1, equation 2, equation 3. I have written 3 inequalities. In all these 3 inequalities, something is missing. Something is incomplete. Nothing is wrong. Everything is correct, but something is incomplete. Can anyone tell me what is incomplete in all these 3 inequalities?
Is less than or equal to x less than 2.
One is less than or equal to x?
Less than 2.
Can you repeat again? X is, repeat this only. Tell me what's wrong here. What is missing?
1 is less than or equal to x less than 2.
Very good, very good. So, what is she saying? She is saying that I am missing an equal to sign here, which means if x is equal to 1, what is the value of y?
1.
Y will also be 1. But if x is equal to 2, what will happen to the value of y?
2.
Y will become equal to 2. So, I go to the previous integer only when either x is greater than 1 or equal to 1. Even if x is equal to 1, it's fine. When x is greater than or equal to 1, x can either be greater than 1 or also equal to 1. I go back to the previous integer. But what is very important, the value of x should be always lesser than 2. The value of x should always be lesser than 2. Because if I put this condition, it's going to be wrong. It's going to be wrong. So what about x? X should be always lesser than 2. Only then I go back to the previous integer. So what is missing in all these inequalities? I have missed a minus sign. Sorry, not a minus sign. I have missed a inequality. Did you understand this point before I go to the next concept? Or yeah?
Yes, sir.
Yes,
Yes, sir.
you all have understood it. Let me ask you one more question. Now, when x is say, let me take minus 2.37. What is the value of y?
Minus 3.
Huh? What is the value of y?
Minus 3.
Minus 3. Y is minus 3. Do you all agree? Anyone wants to give a different answer? Okay. Now, frankly tell me, how many of you did not understand this? Be very frank, because based on that I'll explain. If you have not understood, please raise hands. Okay. Some people from Raibag are raising hands. Okay. Nipani, everyone understands? Nipani, no one raises hands. Okay, I believe that Nipani, everyone understands. Let me explain. Some people have raised hands, which means you have not understood. I'll explain this to you using a very simple number line. People who already know it, please don't feel bored because I'm explaining, because some of our friends don't have a clear idea. Let everyone get a clear picture. Now, let me take a number line, 0, 1, 2, 3. As I told you, if I have a number 2.5, where should I go? I should go to the, where? Previous integer, correct? If I have 2.5, I go to the previous integer. Now, let us write some values here also. This is minus 1, this is minus 2, this is minus 3. Now, where is 0.5 minus 0.5? Is this minus 0.5? Do you agree? Yeah? This is minus 0.5. So what happens? Where should I go? What did I say? Where do we go?
Previous.
To the left, the previous one. So it will be 1. Now, if I have minus 1.5, is minus 1.5 between minus 1 and minus 2? It is between minus 1 and minus 2. Where do we go?
Minus 2.
We go to minus 1. So similarly, if I have a number between minus 2 to minus 3, if I have a number between minus 2 to minus 3, if it is say minus 2.5, where will I go and land? I will go and land at minus 3. I will go and land at minus 3. That is why if I have minus 2.37, where is minus 2.37 for me? Minus 2.37 is somewhere here. This is minus 2.37. Where will I go and land? I will go and land at minus 3. I think now you have a clear understanding. Yes?
Yes, sir.
Now we have a clear understanding. All right. So now I will draw the graph for greatest integer function. One last question before I draw the graph. When x is minus 8.9999, what is y going to be?
Minus
minus
9.
9.
Very good. Y is going to be minus 9. If you are in a confusion, what should you do? Quickly draw the graph 0, minus 8, minus 9. Where is minus 8.999? It is between minus 8 and minus 9. So where will you go and land? Minus 9. If you are in a confusion, quickly draw the number line and then proceed. You will not go wrong. I think now everyone has a clear understanding. Yes?
Yes, sir.
All right, fair enough. All right, fair enough. Now I will draw the graph of greatest integer function. Now we will draw the graph of greatest integer function. Clear? So let me draw the x-axis and the y-axis. Let me draw the x-axis and the y-axis. X-axis and y-axis to understand the greatest integer function. So here we go, plus, rotate. Okay. Now I will take some values and then I will proceed. When x is between 0 and 1, when the value of x is between 0 and 1, what will the value of y be?
0.
Y will be 0. Very good. Y will be 0. Where should I put the inequality? Here. When x is 0, y will be 0. When x is 0, y will be 0. When x is 0.001, what about the value of y?
0.
0.
Still 0. When x is 0.999,
0.
but what happens at x is equal to 1?
1.
Yes, it will become 1. So let me write it in a different color. But when x is 1, y will be equal to 1. So I will just draw this particular graph. Then we will proceed with the other graphs. Okay? Now, y is equal to 0. Can you tell me it is an equation for which line? Y is equal to 0 is equation for one of the lines. Can you tell me which line?
Straight line. Straight line.
Which straight line? I'm being a little specific now. Which straight line?
The
X-axis.
origin.
Who told x-axis?
myPAL class 19.
Nippani 19, is it?
Yes, sir.
Yes, very good. Can you raise your hand, my dear friend? I just wanted to know who's it. Yes, yes, very good. So, y is equal to 0. Y is equal to 0 is basically your x-axis. This is basically your x-axis line. Why is it x-axis? Can you give me some points on x-axis? What about this point here? Can you name the coordinates? Name the coordinates of this point.
0, 1.
1, comma 0.
1, comma 0.
2, comma 0. 0. 3,
0.
minus 1, comma 0.
Minus 2, comma 0. Comma 0.
So, what do you observe throughout that line? Which coordinate is changing and which coordinate is fixed?
Change y is changing, y coordinate is constant.
X coordinate is changing and the y coordinate is fixed. Y coordinate is fixed. So basically equation of this line is y is equal to 0. Please don't get confused. If they tell y is equal to 0 line, it means it is going to be which axis? X axis. One thing please keep in mind, people, when you come across these kind of situations, I think even in the last class we discussed y is equal to k parallel to which axis? X axis. We already came across. Even if a question is asked to me, what is the equation of x axis? What is the equation of y axis? What is the equation of a line parallel to x axis? Even if someone asks me, I will not give a direct answer because even it's a confusion for me to directly tell. So it's better to draw a rough graph. Now can we easily say, correct? If I tell you what is the equation of the line, what is the equation of the line perpendicular to y-axis? What is the equation of the line perpendicular to y-axis? So what will I do?
X equal to 0.
Y equal to 0.
I will draw a line perpendicular to y-axis. Sorry, x-axis. I have drawn a line perpendicular to which axis? X-axis. Start naming the points. Start naming the points. Whatever you want. If say this is 2, this is going to be 2, comma 1. 2 comma 2, 2 comma 3. What is constant throughout? X is constant. So the equation of the line perpendicular to the x axis or parallel to the y axis will be x is equal to, say, x is equal to k. So in less than a minute you can tell the correct answer. So don't by heart. It's very difficult because these are all confusing. These are all confusing. So don't by heart. Rather, just put a quick diagram and then you can decide. Okay? So one of our friends told that y is equal to 0 is x axis. So where should I draw the graph? From where to where? From 0 to 0.99. I should draw y is equal to 0. I should draw y is equal to 0. So let me draw y is equal to 0. From where to where? From x is equal to 0 until, say, this is 1. Say 0 to 1. 0 to 1. All right. Now, this is my, I've drawn the line y is equal to 1. This is my line y is equal to 1. All right. Now, this is y is equal to 0. My bad. I told y is equal to 1. This is y is equal to 0. It is overlapping on the x-axis. Okay. One of these circles is included. One of the circles is not included. Left, right. Can you tell me which is included, which is not included?
Left is included, right is not included.
Left is included because what? Because we have clearly seen that when x is 0, y is also 0. But what happens at 1? This is x is equal to 1. When x is equal to 1, is y 0? Y is not 0. It's not 0, which means I don't include this point. I don't include this point. I hope you are understanding, people? Catching up? Yeah?
Yes,
So,
sir.
so as some of you told, which one should I darken? I should just darken the circle on the left. So, what does this mean? This means that, this means when x is 0, y is also 0. What is happening here? X is 1. Is y 0 there? No. Y is not equal to 0. Y will be equal to 1. That's why I have not darkened it. I think it's very clear why we are darkening on one side. Included, not included. All clear? Yeah?
Yes, sir.
Yes. Because continuity, whenever they ask, I mean, it's a board exam question, it's not from CET. If they ask the continuity of a greatest integer function, you have to draw the graph. It is compulsory part of the solution. And what will students do? Students will just know that it's a graph like this. They will know that the graph is like this. They will not know which is darkened and which is not darkened. What will students do? Wherever they want, they will just play one game and come back. They will not know. So you should know where it is darkened, where it is not darkened. Okay? You should not do it. You should not do it roughly. You should not do it roughly. All right. Here we go. Here we go. Now I go to the next point. I'll just only discuss 2 points. We have discussed at 0. One I'll discuss on the positive side. One we'll discuss on the negative side. Then the same story continues. Now let me go to the point between 1 to 2. Let me go talk about a point from 1 to 2. So, when x is equal to, say, when x is between 1 and 2, I will include 1, but I will not include 2. Okay? Include. So, when x is 1, what is y?
1.
1. X is 1.001. Y is?
1.
X is 1.999. Y is?
1.
1. But when x is 2, what about y?
2.
Y is 2. That's why I have written with a different color. It's not happening. So, this is my point 1. Is this my point y is equal to 1? This is my point y is equal to 1. So, what is happening? When x is 1, y is 1. When x is 1, y is 1 until where? Until 2. Until 2. From here to here I have the line. From here to here I have the line. I have to darken one of the circles and one of the circles is not included. One of the circles is not included. Which circle is included, left or right?
Left included.
Left, because at this point, what is the value of x here, people, at this point?
1. 1.
Yes, x is 1 here, x is 1. And what did we discuss? When x is 1, y should be 1. So this is included. This is included. When x is 1, y is 1. What is this point here? What is the value of x at this point?
2.
2. When x is 2, is y 2?
No, sir.
Sir.
Y is, sorry, is y 1? My bad. Is y going to be equal to 1? No.
Yes.
No, sir.
Y is not equal to 1. That's why I am not including that point. I am not including but that point. Only this point is included and this is not included. I think you have a better understanding now. Yes?
Yes, sir.
All of you catching up, friends? Yes?
Yes, sir.
Everyone? Yes. Please raise your hands so that I understand that you understand. If you don't understand, please try to understand that I'm trying to make you understand. Is it clear? Did you understand what statement I made? Okay, I don't know. All right? Even if you did not understand that statement, it's fine. But please try to understand that I'm making you understand. Clear? If you have any doubts, please do ask. If you have any doubts, please do ask. All right, I'll go to the last point. We'll go to 1 point on the left. If you have understood this, 1 point on the right, 1 point on the left is more than sufficient. We need not explain this for all the points. It's the same story. It's going to be the same story. Now, I will go to on this side. Let's go on this side. Let me take the value of x between -1 to 0. Between -1 to 0. Now, when x is equal to 0, what is the value of y?
-1.
Yes, 1.
When x is 0,
0.
it will be 0, not -1. X is 0, y is 0. Let me go to the left of x. That is on the negative side, -0.001. What is y?
-1.
-1. X is equal to -0.999. What is y?
-1.
When x is -1, what is the value of y?
-1.
It will be -1. So I am including the point. I am including the point -1, but I am not including y is equal to 0. Now, I will draw the line y is equal to -1. If you observe, y is -1, y is -1, y is -1 for all these values for x. But x is equal to 0 when y is equal to. So y is equal to -1. It is a line parallel to which axis? Y is equal to -1. Parallel to?
X-axis.
X-axis. So I have a line parallel to x-axis. So from where? When x is, okay, I'll draw the line. I have to include, which should I include, left or right?
Left.
Left is included, right is not included. Do you agree?
Yes.
Sir.
Yes.
Sir.
Left is included, but right is not included, Now, at this particular point, what is the value of x, people? Can anyone tell me what is the value of x on this point?
0.
X is 0. Yake? Because any point on y-axis. It is of what format? What's the format of the point? General
0,
point? Huh?
0,
0 comma y.
No,
Correct.
one.
0 comma minus y or 0 comma y. So throughout the y-axis, can I say x coordinate is 0?
Yes.
Throughout
Yes,
the
sir.
y-axis, x coordinate is 0. So what is one more name for y-axis? One more name for y-axis is x is equal to 0. So if they say the line is x is equal to 0, they are talking about y-axis, because throughout the y-axis, if you plot all the points on y-axis, the x coordinate on those points will be, the x coordinate of those points will be 0. So this is the point, x is 0. When x is 0, we have already discussed what should be y? Y should be 0. But is y 0 here? No. What is the value of y here? Y is minus 1. So y is minus 1. What is this point for me? What is this point for me? X is? What is this point?
-1, sir.
X is minus 1. When x is minus 1, what is the value of y? Y should also be minus 1. That is why it is the included point. That is why it is the included point. Are you understanding? Yes?
Sir.
Sir.
Artha ಆಗ್ತಿದ್ಯಾ?
Yes,
I think the clarity on continuity is becoming better. Do you agree?
Yes, sir.
Sir.
Or is it becoming discontinuous?
No, sir.
Continuous or discontinuous?
Continuous.
Continuous. Continuous when you are in class. Discontinuous when you are out of the class. Correct? Is that so? Yeah? At all points, it should be continuous at all the time. You should not say time is equal to 12 o'clock to 1 o'clock continuous. Then after 12 o'clock to 1 o'clock, remaining time discontinuous. That should not happen, people. Yeah? It should be continuous all the time. All right, students, are you understanding? Yes?
Yes, sir.
Okay, all right. So we have understood the greatest integer function. Now I want to understand how is the weather at your place. How is it now? Is it raining? Is it cold? Is it hot? How is the weather, people, at all your places?
Normal.
Normal. Very good answer.
Cold, sir.
Cold. Where is it cold? Who told cold? Raibag, is it?
Sir.
Raibag is cold? Okay. What about Nipani?
Sunny.
Sunny. All right, all right. Is it not raining anywhere? Has it stopped raining?
Yes, sir.
Yes.
Sir.
Because in Bangalore it was raining for 2 months. Was it also raining continuously for few days, few weeks?
No, sir.
It was not raining. Okay. Bangalore from past 1 or 2 weeks it is not raining. But July and August month it was raining so much we had to use boat for transportation. It had become like that. Bangalore had become so worst because especially the roads are very bad. Okay, if you are coming to Bangalore, please keep in mind the roads are very, very, very bad. You will tell that nam halliyale road chanagide. That statement you will make. Bangalore roads are so bad. All right, and that too when it is raining, you don't know the holes are so deep. The holes are so deep. You have to go with a life jacket when you are walking because suddenly the water will come till here. It is so deep. If you step, the water will be until here. So you should wear life jacket and go so that you start floating. So either you had to swim or go by boat. The condition was so bad in Bangalore. But your places, it was good. That is nice. All right. But I think, have you seen in other parts of the country? It was very bad in North India, Northeast India. I think you saw the news. You saw so many videos maybe, right? The
Yes.
condition
Yes, sir.
was very bad, especially this year. The weather was not supporting. And in many places, there were many people lost their lives. It was a very bad condition. But to be frank, people, we in Karnataka, we are on one of the safest places. In Karnataka, it's one of the safest places because even Tamil Nadu is facing problem, even Andhra Pradesh is facing problem, and even when you go to
Punjab,
North
sir.
India, they all are facing problems with respect to the weather conditions. But Karnataka is a very safe place. Karnataka is a very safe place. On top of that, to be frank, South Karnataka is even more safer. South Karnataka, especially this Bangalore, Mysore region, all these regions, it's very safe with respect to the natural disasters. I'll tell you the reason why. I'm slightly deviating. The region, I'm not telling because I'm in Bangalore, I'm not telling it is safe. All right, that's not the reason. That's not the reason. The reason is this region of South Karnataka, especially middle and South Karnataka, it comes under Deccan Plateau. It comes under Deccan Plateau. Have you come across this word Deccan Plateau in social? Yeah? Yes, maybe? So this Deccan Plateau, this region was formed millions of years ago. Many years ago, Deccan Plateau was formed. That is, even before humans were formed, this region of Deccan Plateau was formed millions of years ago. Because this region is formed millions of years ago, it's a very stable region. Even earthquake, floods, and all these things are not possible on these regions because it was formed millions of years ago. It's a very stable region. So we in Karnataka, we are in a very safe place. All right, it's a very safe place, but only with respect to natural disasters. With respect to politics, definitely not safe. With respect to politics, Karnataka is definitely not safe. Do you all agree with that? Yeah?
Yes, sir.
Yes. Oh, so with respect to natural disasters, we are safe, but politics is disaster in our country, in our state. Yeah, Sidramaya and his team, they're all disastrous people. Okay? Fine? All right. So, this is not needed. So, we have discussed about what? We have discussed about we have discussed about the greatest integer function. Now, we'll quickly go into a couple of basic simple examples to understand continuity. So before going to that, I'll just give you the difference between what is going to be continuous function, what is the difference between limit and continuity. I'll just give you a basic difference between limit and continuity so that we have a good understanding. So let me take limit of f of x, limit of f of x at x is equal to a, and let me talk about continuity of f of x, continuity of f of x at x is equal to a, at x is equal to a. Let's try to understand this statement very well. Let's try to understand the statement very well, okay? Because you have already come across limits and you already know continuity, but you don't know the actual difference between what is limit and continuity. Am I correct, people? You have come across both the words. You have come across limits, you have also come across continuity, but you don't have an actual idea of what exactly is limit and what exactly is continuity. So first I'll tell this information and then we'll proceed further. Now, whenever I talk about limit of a function, we are talking about value of the function. Limit means we are discussing, the discussion is about what? We are discussing about the value of the function, in the neighborhood of f of x, in the neighborhood of f of x. So we are talking how the function is behaving not at x is equal to a, but how the function is behaving to the left and to the right. That is limit. Clear? We are not at all talking about what is happening at f of x. So we are discussing about what? We are discussing about the value of f of x. Okay? Value or behavior of f of x. How it is behaving. Value or behavior of f of x in the neighborhood of f of x. What do I mean by neighborhood? What do I mean by neighborhood? Yes?
Immediate number.
Yes, left and right. Whenever I use the word left and right, we are talking about immediate left, immediate right. Please keep in mind, I will not use the word immediate. It is understood that we are talking about left and right, immediate left and immediate right. So what exactly is happening in the limits? We are not discussing about what is happening to you. We are discussing about what is happening to your friends next to you. Clear? But when I talk about continuity, continuity means we are talking about what? We are discussing about value of f of x, value of f of x in the neighborhood of x. I had to write x here. I have written f of x in the neighborhood of x basically. Okay, we are talking about neighborhood of x. Okay, value of f of x in the neighborhood of x. Here continuity means we are discussing about value of f of x in the neighborhood of x. That is left and right. Also we are discussing about the value of f of x. We are also discussing about value of f of x at x is equal to a. At x is equal to a. I hope you have a slight understanding again. Limits, we are not worried about what is happening to me in limits. I'm worried about what is happening to my neighbors. But when I talk about my continuity, I'm worried about me and I'm also worried about my neighbors. I hope you have got an idea. What's the difference between limits and continuity? All right.
Yes, sir.
Now let us take. So that is why whenever we discuss about continuity, I told you whenever we discuss about continuity, we don't just discuss about LHL and RHL. We discuss about LHL, RHL, and it should also be equal to, as one of you told, it should also be equal to what? Value of the function at that particular point. It should also be equal to value of the function at that particular point. Okay. So so what is going to happen if I write about LHL and RHL? If I talk about LHL and RHL, so we'll put a statement now. A function is said to be continuous. A function is said to be continuous. A function is said to be continuous. It's said to be continuous at x is equal to a. At x is equal to a, if the following conditions are satisfied. If the following conditions are satisfied, the function f of x should be defined at x is equal to a. What do I mean by defined at x is equal to a? At x is equal to a, I should not have an undefined value. I should not have an undefined value. What do you mean by undefined value? For example, infinity. Very good, very good. So example I will write here so that you understand the meaning of the statement. So when I say f of x is defined, say f of x is say I will say let me take a simple example. Say f of x is 1 by sine x. Say f of x is 1 by sine x. What happens at x is equal to pi? At x is equal to pi. What is the value of f of x?
0, infinity.
It is going to be 1 divided by 0, which is going to be infinity or not defined. It is not going to be defined, correct? I'll write ND. It is not defined. It is not defined. I hope it's clear. It is not defined. So we cannot discuss continuity. We cannot discuss continuity at which point? At x is equal to pi. I hope you are understanding the meaning of that statement. What is point number 1? A function is said to be continuous at x is equal to a if the function is defined at x is equal to a. If the function is defined at x is equal to a. Point number 2. Limit as x tends to a. F of x should be equal to value of the function at f of x. So how do I read this if I verbally use this statement? Limit of f of x, where limit of f of x as x tends to a. What do I mean by x tends to a? In the neighborhood of a. In the neighborhood of a should be equal to what? This is what? Value of the function, because these are the statements that we'll be using. Value of the function at x is equal to a. So this is condition number 2. Limit of the function in the neighborhood of a should be equal to value of the function at a. And what about the last point? The left hand limit. Left hand limit means as x tends to a minus. This is what? Left hand limit. When I say x tends to a minus, I am not saying a is negative. What do I mean by a minus? On the left of a, correct? What do I mean by a minus? Values of a. A minus means values of x on left of a. Values of x on left of a. So this should be equal to limit of x tends to a minus f of x should be equal to limit of f of x as x tends to a plus. What do I mean by a plus? What do I mean by a plus? What is A
Values
plus,
of
people?
x on right
Yes,
of
values of x on right of A, on right of A. So these two should be equal, and it should also be equal to what? It should be equal to
value
the
of
value of the function. If all these conditions are satisfied, then we can say that the function is continuous. First, we should check if the function is defined at x is equal to A. Okay. Then I should check if the limit of the function is equal to value of the function. If that is also happening, I should also check if the left hand limit and the right hand limit are same. I should also check. So this is basically LHL is equal to RHL. This is nothing but LHL is equal to RHL is what we need to check. And if it is also equal to value of the function, it is also equal to value of the function. I hope there's a clear understanding of continuity, people. All the basic concepts are clear, I believe. Yeah?
yes,
Yes, sir.
Yes. As I told, please do revise. Make sure it's very thorough, because the reason is students in general, they lose marks in questions based on continuity. And in order to get a good rank, you have to do questions correctly, which most of the people could not do. Only then you will surpass them. I hope you are understanding. Okay?
yes,
If you
sir.
have to get a good rank, it's basically you have to cross the people where people could not cross a certain question. If you solve those questions, automatically you start coming on the top. All right? Yeah? So next class, I will start with some simple CET questions of continuity. All right?
Yes, sir.
Yes, sir.
Bye. Do well with your test on Saturday.
Bye, sir.
Yeah.
Thank you.
Bye, sir.